Good afternoon, everyone. I'd like to thank you all for joining us today in our weekly webinar series. Today our featured topic is Fusion Splicer and Cleaver maintenance. My name is Jessica Petrohoy and I'm the marketing coordinator at fiberoptic.com. Fiberoptic.com is the leading provider of fiber optic products, training, and rental equipment. We're pleased to present this topic to you today. With us today to talk about Fusion Splicer and Cleaver maintenance is Bob Harlow. Bob is a production assistant and customer service agent for Precision Rate Optics with over 15 years in the telecommunications industry. Bob will be reviewing splice verification, cleaning your splicer, replacing electrodes, cleaver blade rotation, and more. When Bob is finished, we'll take questions from the GoToWebinar question box at the bottom of the screen for a question and answer session. So if any time you have questions, just leave them in the question box and we'll get to them at the end. And as always, our webinars are posted at fiberoptic.com/webinar. So thank you again for joining us today, and at this time I turn the presentation over to Bob.
Hello, my name is Bob Harlow. I work for Precision Rated Optics. I take care of all the splicing, splicers, maintain, and calibrate any and all splicers that come into our company. Today's agenda, we will be going over Fusion Splicer maintenance, Splice Evaluation, cleaning, electrode replacement, arc calibration / arc test, cleaver maintenance, cleaver evaluation, cleaning, blade rotation, blade height adjustment. Mechanics of a splicer. Let's get familiar with some of the terminology. On the screen here, you'll see on the right side, or excuse me, the left side, you will have fiber alignment guides, V-groove normally. In the middle, you will have fiber illumination LEDs. Basically, these light up so the machine can see the fiber. And then on the right, you will have motor operated sleds. These are normally called fiber holders. Also, on the left-hand side, you will have magnetic latches that keep the fiber in place. In the center, or excuse me, the bottom left would be primary fiber retention cleat, which is basically a hinge for the fiber holder. And on the other side, the right side, retention pad. This keeps the fiber from sliding. And then you will have underneath the electrodes, you have 2 CCD cameras for fiber viewing. And then of course you have your electrodes, the most important part other than the cleaver for you to do your splicing. You will see in our diagram here these 2 orange fibers. Fiber is manually inserted into the splice bed. This area is located between the center apex of the electrode and the outside edge of the V-groove. Use caution. Do not contact the end face of the fiber to the V-groove. Then flip down the retention cleat or fiber holder. Be sure to install heat shrink first or a splice sleeve. Here we have examples of good splices that are acceptable in the field. The first one, white line. Second one, blurred thin line. Third, offset. Fourth, diameter difference. Fifth, dirt on the fiber. Visually inspect splices after the program has run using both Y and X views. Sometimes you can flip through them on different machines. Some flaws that do not affect optical transmission are acceptable as shown. Some fibers, fluorine doped or titanium coated, may cause white or black lines in splice regions that are not faults. Bad splices. Some flaws are unacceptable and require starting and splicing process over. Some, like black spots or lines, can be improved by repeating the arc step but never more than twice. For large core offset bubbles or bulging splices, always redo. You'll see a bubble, a bulge, examples of a bulge in a splice, thin black line, and a black shadow. Bubble or inclusion, contaminated fiber and end faces, poor cleave, fusion current too high, pre-fusion current or time too low. Very important that you understand how your splicer works in single mode and multi-mode. Single mode, you need a longer heat, a higher temperature for a longer time. Multi-mode, a lower temperature for a shorter period of time. Enlargement. This happens when auto feed is too fast and incorrect current. Not fused through. That's pretty obvious. You'll notice, the vision that you'll see, the fusion current is too low, pre-fusion time is too short. You'll know right away by looking at it that it's not fused through properly. Constrictions. Now, sometimes contaminated electrodes will cause this. Pre-fusion current is too high, pre-fusion time is too long, current too high, feed rate is too slow, and the gap is too wide. Match heads. This sometimes is referred to as what would be a arc calibration. When the machine does this, sometimes electrodes are contaminated, the fusion current much too high, pre-fusion time much too long, pre-fusion current much too high, auto feed too small, gap too large. A lot of things to take notice when you are splicing. Splicer cleaning. Cleaning V-grooves and bare fiber pads. This is very important. V-grooves are the precision guides that keep the bare fiber aligned for splicing. Bare fiber clamps hold the fiber seated into the V-grooves. Sometimes tiny bits of dirt or coating residue cladding can get caught in the grooves or on the pad of the clamps. The fiber diameters to be offset will create poor splices. What you need to do, and I find the best thing for cleaning, is using 99% pure alcohol. V-groove cleaning brush and a tight woven lint-free cotton swab. That's my favorite. And of course, no canned air is sprayed in or around the electrodes or the cameras. Cleaning V-grooves and bare fiber pads. Procedure. 1. Moisten the V-groove cleaning brush with alcohol and brush the V-groove outward, away from the electrodes. This is to prevent dust from falling on the microscope lenses. Use firm pressure to clean the bare fiber pads with a cotton swab moistened with alcohol. Go over the same area with a dry cotton swab to remove any excess alcohol. So you make sure you just always have 2 with you when you're cleaning the V-grooves. Cleaning the mirror, the LED mirror covers. Alcohol and lint-free cotton swabs. Moisten the cotton swab with the alcohol. Gently wipe the mirror surface. Use a second one to dry cotton swab to wipe off any excess alcohol. Cleaning the microscope lenses. This is very important. You will need alcohol, 99%, and cotton swabs. There are 2 microscopes between the V-grooves in the Fusion Splicer stage area for viewing the fiber to be spliced. Large dirt particles on the microscope lenses can reduce the ability to inspect fiber and will yield inaccurate results. Basically, anything that's obstructing in those cameras is going to make the image either move up and down, or it's going to bring them in and you won't be able to do anything with the splicer at all until you get to clean the microscope lenses. Cleaning the microscope lenses is very important. 1, turn the Fusion Splicer off and open the cover to reveal the splicing area. Remove the front and rear electrode to expose the lens surfaces. Each lens lies below the electrode at 45-degree angle. Gently clean each lens with a cotton swab, moistened with a small amount of alcohol. Clean in a spiral motion from the center of the lens and working out to the edge. 4, wipe each lens again with a clean, dry cotton swab to dry the alcohol, thus avoiding spots. This is very important, the electrodes. This is what makes your splicing a good splice to a bad splice. Electrodes will typically need replacing after approximately 2,000 discharges. And all splicers will have a count of this in the menu options. So at any given time, you can go through to see how many splices you've had. And when it gets up there, the electrodes will have a certain color at the very tip that also is a sign to let you know, hey, these things may need to be replaced. And replacing the Fusion Splicer maintains a count of the number of arc discharges. This procedure includes instructions about resetting the counter to 0 after replacing the electrodes and conditioning the tips. Remove old electrodes. First, turn off the Fusion Splicer and unplug its power cord. Using your fingers, loosen the thumb screws to remove the electrode cover plate. Remove the old electrodes and discard. Note, while you have the electrode cover plates off, take a look at the mirrors. Make sure there's no debris around the edges or directly in the center of it. So while the electrodes are out, carefully check for dirt on the microscope lenses. When handling the electrodes, avoid touching the metal portion with your skin. Skin oil left on the electrode will deteriorate performance. If touched, clean with alcohol and gauze. Electrode cover plate thumb screw. Installing new electrodes. Before installing new electrodes, gently clean the electrode with a pure alcohol and gauze wipe. Holding the electrode by the plastic button, place the electrode in the retaining groove. When replacing the electrode cover plates, push the plastic button against the clamp wall to place the electrode tips at the correct distance. Ensure the beveled edges on the electrode cover plates are facing inward toward each other. Gently tighten the retaining thumb screws. Do not over tighten. Very important that these things are pushed back to where they originally were when you took them off. If there's any problem, if there's any issue, if it's not seated right, you will not have any success with your splicer. After changing the electrodes, there are some things you need to do. One, you can reset your arc count. Two, perform conditioning arc. This is basically in the menu of splicers. There is a stabilizing, electrode stabilizing setting. It is important that you stabilize your electrodes. This basically gets them primed for working properly. And then you will then do an arc calibration. This gets the machine calibrated to the environment that you are in, plus it gets your electrodes ready for the next session of fiber that you will be splicing. It is important that you do the arc calibration until you get arc OK stated on the splicer. If you don't, you have to continue to do an arc calibration until you get the machine to work properly. And 9 times out of 10, they tell you arc OK. When should we do arc calibration and arc test? This is important because a lot of times you will be working with single mode and multi-mode. One floor may be single mode, and then your distribution from room to room will be multi-mode. So when you're going from multi-mode to single mode, it is very important to do an arc calibration. Why do we do this? Changing fiber types, changing splice locations, initial splicing setup, extreme changes in temperature and humidity. Meaning if you are inside a cool building and you go outside, there will be a temperature change that the machine will pick up right away. You just cannot start to splice as soon as you get outside. You need to do an arc calibration to get the machine acclimated in the environment that you are working in. If you are outside, you will be either in a van, the back of a van, or in a tent. This is ideal conditions for splicing. Open air is not an ideal condition. Poor splice performance. If you're splicing and you're getting high losses on your splices, this is another time to take the time to do an arc calibration. It resets the machine, again, to the environment that you're working in. It's very important that you know how, and if it's raining out, you're not going to be splicing outside. You're going to be in a tent or a bucket truck. Temperature, if it's cold, you have to be inside with a heater. Another thing to keep an eye on when you're doing these arc calibration is, if you haven't, look at the electrodes. The electrodes will show you signs of time to change them. This will also cause poor splices. And after each electrode replacement, you do an arc test. Very important. It's very important that you get in the habit, as soon as you turn this machine on, you just get yourself some bare fiber, take 15 minutes. A lot of guys don't have it, but I'm telling you, it will save you in the long run. What is an arc calibration / arc test? The Fusion Splicer has a built-in arc test feature that should be used to ensure consistent, high-quality splices. Most places that I've encountered and worked in will not allow anything over a .01. So it's important that your splicer is in top condition all the time. You want either a .00 or a .01 minimum. Anything higher than that, most places will make you reburn. Performing an arc test automatically adjusts the arc power level for the splicing program selected. You will center the fiber end faces relative to the arc heat zone. The adjusted arc conditions are retained when the splicer is turned off. So you're done splicing in one area, and then you're going to take a break, eat lunch, and then you're going to splice again if you do this. All you got to do is turn it on. You do not have to do an arc calibration. It is set. If you were to take this machine outside or move to another area of the building, yes, you will. This will ensure proper splicing performance. Now we're on to cleaver maintenance. This is very important. It's the most important thing. If you have a bad cleave, you won't be splicing much. So for what I have here, I have an FSC81, exactly what you see on the screen here. The bottom right-hand picture is what you're striving for when you go to do your cleave. It is sometimes difficult to get an absolute perfect cleave, but it is crucial that you strive to have the best cleave possible. On the left, you will see 3 examples of poor cleaves. The top one, obviously, it won't meet up. The middle one, it could meet up, but you're going to have some form of bubble when it goes to splice because there's a chip at it. And then the bottom one, it's just cracked, broken. It won't. There's no way it will splice together. So you always want a perfect, close to perfect cleave as possible. Areas to clean include, very important that you take some time to do this. On the top left, fiber grooves. You have 2 grooves, one for 900 micron, the other one for 250/125. I like to take a piece of just bare fiber and run it through the grooves. You can then take alcohol wipe and just run it through. Then on the right-hand side, your rubber pads. Very important that these outer pads are kept clean. If you have dirt and debris on the top or bottom, it will cause your cleave to be off in some way, shape, or form. So it's good to take alcohol and rub the 4 pads that are on the top of the lid and the base of the cleaver. And this is the most important part, and I try to emphasize this when I'm dealing with techs when I'm cleaning and calibrating their cleavers. In the morning and at the end of the day, take a swab and just clean the top of the edge of the blade. This will make the blade last so much longer. And with how the blade is properly adjusted and goes through the life of the blade, doing this is very important. Notes: dust on the blade's edge will diminish cleaver performance. Very important. Use alcohol. Pay attention to remove any fiber shards from the top pad. This will cause poor quality cleaves.
So when I'm cleaving, I want to make especially sure that this pad and this pad are clean, because as the cleaver blade moves under, if these pads are not clean, fiber itself can move, and I'll get an angled cleave rather than a straight cleave.
Rotating the blade. The cleaver blade should be rotated after approximately 1,000 cleaves. This is going to be something that a tech wants to keep in mind, because if you have a bad cleave, you're going to have to redo it. So making sure you have somewhat of a good memory, or jot it down. You did 50 cleaves for the day. Just keep in mind for the rotation of the blade. Dull blades will often leave a lip or display a crack in the cleave. When this begins to occur, rotate the blade according to the manufacturer's procedures. Typical procedure. For this cleaver, loosen the blade set screw. Rotate the blade 2 positions using a cotton swab. Do not touch the blade with bare hands. Do not rotate with metallic tweezers. Blade is typically rotated toward the front of the cleaver. Tighten the blade set screw. Do not over tighten. This could cause wear on the screw. Test cleave and view in a splicer. This is the only way you will be able to test and see how well your cleave is. Blade height adjustment, very important. After the blade has been rotated through all positions, the blade height must be raised. The blade can then be rotated as needed through another series of positions. The height can be adjusted twice to give a total of 3 full series of blade rotations. So every time you rotate the blade fully from 1 to 12, you raise. You will be able to do it again, raising it for a second, and then the third and final time. This way you know your blade is getting the full life of its expectancy. Typical procedure for blade height adjustment. As you see here, loosen the locking screw for the blade height. Rotate the blade height adjustment screw, turning in a clockwise direction, typically raises the blade height. Do not over adjust. Tighten the locking screw for blade height. Do not over tighten. This may damage the blade. Blade replacement. When to replace? When the blade has made 3 complete series of rotations at all three blade heights positions, the blade must be replaced. If the blade is damaged due to over tightening of the set screw, of improper handling, the blade will need to be replaced. That's why it's very important for technicians to just document as much as you can the amount of times you've cleaved with the cleaver. It's just going to save you time in the long run, knowing or asking, hey, does this blade need to be checked? Does this blade need to be rotated? If you keep a little note, same with our calibration, just keep it in the box, the cleaver box, your splicer box, anything, just to let another tech know that this blade, has this amount of cleaves on it. Typical procedure, blade replacement. Unscrew and remove the blade set screw. Remove the blade with tweezers. This is the only time you will be able to touch the blade with tweezers when you are replacing it. Insert a new blade with 1 position at the top. They all from 1 to 12 or from 1 to 16. Always 1 is pointing straight up. Use care. Do not damage the blade during placement. Do not touch the blade with bare hands. Very important. You have oil on your hand. Do not touch it. If by chance you do, quickly clean it. This way you know you're ready to go. Replace and tighten the set screw while holding the blade in place. You can get another cotton swab, just tightly press up against the blade and just tighten the screw, just nothing over tightened. Adjust the blade height to the lowest setting. This is the end of our session, webinar. If you have any questions, please feel free to jot them down, and I will answer anything that you have. What is pre-fusion time? That all depends on the splicer that you have. The one that I have set in front of me is a Pro 810, and the pre-fusion time typically is within nanoseconds, because what happens is the machine is building up electrical current, and then it's releasing it when it's time to splice. So the pre-fusion time can vary. Not all of them are set the same way. The reason why we need to do an arc calibration is we need to acclimate the splicer to the environment that you're working in. If you're in an outside and it's cold, you're going to have to get some form of heater to get your splicer to be acclimated to a temperature that's ideal for that machine to work in. If it's 40 degrees, it's not going to work good. If it's 90 degrees, it's not going to work good. You got to get some form of temperature where the splicer will work properly. Yes, there is a way you can test for the height. There are numerous things you can get. You can get bare fiber and just prep the fiber like you're ready to put it in the splicer. Or there's also a simple way of using a toothpick. Lay the toothpick in the grooves, preferably the 900, and then just go and lightly go across the toothpick. At your height, it should leave a mark, but you don't want to do it where it cuts the toothpick. It just wants to leave a slight impression. The alcohol should be 99% isopropylene alcohol. That is the best. Hello from Ecuador. I understand your situation because I know we're not allowed to ship alcohol outside of the state, let alone air. So in the company that I work for, we have a special substitute that is used for cleaning as good as alcohol does. It's in a pump spray. It allows you to it allows you to prep your fiber the same way, but without the alcohol. This type of cleaning is used in areas where alcohol is not permitted. And when we fly things to other states and other countries, we have to ship them this type of cleaning solution. You're very welcome. All right, well, that wraps up for today. Thank you, everyone, for joining us